Hello, everyone, and welcome. So my name is Jaskolka, and I'm an assistant professor in the Department of Systems and Computer Engineering, and I'm the director of the Cybersecurity Evaluation and Assurance Research Lab at Carleton University in Ottawa, Ontario, Canada. We're pleased to be hosting this session of SECREV 2021 titled Practical Approaches for Securing Critical Infrastructure. So critical infrastructure refers to all of the processes, the systems, the facilities, the technologies, the networks, the assets, and all the services that are essential to the health, the safety, the security, and the economic well-being of the public and of the effective functioning of government. Critical infrastructure represents some of the most security critical and safety critical systems in our modern society. So some examples of these systems include advanced manufacturing systems like mechanical systems, chemical processing, advanced metering infrastructure for energy grids, wastewater control systems, multimodal, that is maritime, rail, and ground transportation systems, nuclear command and control, connected e-health systems, autonomous vehicle infrastructure, satellite communications infrastructure, stock market trading systems, and so many more. These systems are often cyber-physical in nature, and they contain numerous software and hardware components. They also employ a wide variety of emerging technologies, such as cloud computing, distributed computing, big data, and the Internet of Things, just to name a few. In this session, the presentations and discussion are going to explore some practical ways to address the many cross-cutting and multifaceted and multidisciplinary security challenges and considerations that need to be taken into account when securing critical infrastructure. And that is where we're going to start with our first presentation. So I will be giving our first presentation today, and it's going to be titled Effective Security Assurance for Critical Infrastructure, Current Challenges and Future Directions. So we'll just take a second to get the slides up here, and we will be underway. So in this talk, we're going to look at a number of different challenges and directions for providing effective security assurance for critical infrastructure systems. Now, when we consider critical infrastructure, we can look at them in 10 different sectors. In Canada, we have 10 sectors of critical infrastructure, and these cover health systems, food and food processing systems, water and wastewater treatment facilities, all of our safety services, such as emergency services, manufacturing systems, all those systems that are essential to the appropriate and effective functioning of government, our financial systems, our transportation systems, energy and utilities, and all of the information and communication technology that we have as well. So when we consider these critical infrastructure sectors, over the past 2 decades or so, a number of these sectors have undergone a substantial modernization towards the next generation. We're starting to see much more modernization and digitalization of these systems. And with this comes the introduction of new systems with this added digitalization, communication, and numerous automation technologies. And the result of this is that our critical infrastructures have now become these transcontinental cyber-physical infrastructures that have evolving forms of information collection, analysis, and exchange between the different providers and customers. So it's not hard to think about why we need to worry about the security of such infrastructure. The safe, the secure, and the reliable operation of the nation's critical infrastructure is important for the health and the welfare of the economy. And with this modernization and digitalization, we get promises of more efficient and more sustainable services. And there are also promises of improved reliability and security. And with this brings a new frontier of security and resilience challenges. And that becomes something that we really need to start worrying about. These newly emerging security and resilience challenges include a number of different things. We need to look at defenses against cyber or physical attacks and failures. We also need to consider the protection and privacy of sensitive consumer information that's being collected by these different infrastructures. So the manufacturers, the owners, the operators of all of the different components and devices and systems that make up our critical infrastructure need to strive to ensure such challenges have been adequately addressed so that we can have some confidence in these services that are provided by these infrastructure systems. So why do we need security assurance? Well, when we consider attacks or failures on critical infrastructure systems, these could have disastrous consequences and many destabilizing effects on all of the dependent systems, the humans, the environment, and the economy as well. And when we look at engineering these high assurance systems, these systems that require strong confidence and assurance and justification that they have adequately addressed all of their security concerns, we have to place a strong emphasis on the rigorous requirements and specifications, the verification and validation of these systems, risk management, as well as certification. And we also need to provide guarantees that are backed by a verifiable body of evidence that these systems are going to function exactly as they're intended to at all times during their operation and during their lifetime. So ways of providing security assurance for these different types of systems are growing in importance and are sought after by many different research and development programs that are initiated by governments and providers of critical services. So we want to try to fulfill this need. So when we consider why we need to be focusing on security assurance for these new modern digital critical infrastructures, we have to consider the different threat factors that are in place that are contributing to the challenges of securing such infrastructure. So the first is that there's a rapid pace of technology. It means that these systems are rapidly changing. They are becoming more modern, more digital. And this is something that we need to worry about when we're securing these systems, because we need to keep up with the rapid changes that are happening in these spaces. We also have to consider the technological complexity of these particular systems. And as we continue to modernize and digitalize our critical infrastructure, we're only increasing the complexity of these systems, which makes understanding the different attack vectors within these critical infrastructures that more difficult to uncover. All of these infrastructures with modernization and digitalization are also finding increases in data sharing and interconnectivity. So what this means is that we have to worry about all of the data that such systems are collecting and how that data is being collected, stored, and shared among all of the different interconnected systems that we may have. Beyond that, we have to be aware that there's a rising sophistication of cyber attacks and cyber attackers. It's that the cyber attackers that we're seeing today are no longer just those folks that are doing this for the thrill from their basements, for example, but rather these are now sophisticated attack campaigns that are well funded and that have specific purposes to disrupt critical infrastructure. So we have to keep this in mind when we are considering how we're going to address the challenges of securing such infrastructures. And then finally, there's the attractiveness of critical infrastructure as a cyber target. What this means is that we have to consider the fact that these systems are a ripe target to cause a lot of disruption in our society and in our economy. And a recent example of the Colonial Pipeline is a perfect example of this. It's that we have these cyber targets that when they are attacked, it causes quite a lot of disruption to the normal functioning of our society. On top of these threat factors, we also have a number of different cybersecurity concerns that contribute to the challenges that we face. So the issues here are that we have this increased connectivity. And this is a major concern when we consider how we are going to be addressing security of our critical infrastructure. We no longer have these systems that are closed systems. They're now becoming much more open and connected to the internet, and they are connected to other dependent systems, which means that any issue in those systems can cascade and cause disruptions to other adjacent systems. These systems are also collecting huge amounts of data. So questions about preserving the confidentiality and privacy of such data, especially as it relates to consumer data, is becoming an increasingly important problem to solve. I've also mentioned that there's the size and complexity of these systems, and this continues to grow day by day by day. If we consider, for example, our energy grid, this is probably one of the largest and most complex systems that humans have ever invented. And therefore, it becomes very challenging to figure out how we're going to go and address the security challenges of such a system. It's very difficult to just even understand how that system works as an entire whole, let alone all of the intricate security vulnerabilities that may exist in those systems. When we consider critical infrastructure, we're also seeing a convergence between information technology systems and operational technology systems. We now have a wide range of cyber components that are being added to these systems that are meant to control processes to give us more effective control over those processes. But with that comes a whole new frontier of challenges that need to be addressed. Of course, critical infrastructure systems with their size and complexity are not built entirely of components and services that are developed in-house by owners and operators. They rely on third-party services and supply chains, and this presents a very difficult challenge to solve when it comes to securing these systems. We have to then look at how these different parts are being acquired and being used in the development of these systems. There is a lack of cybersecurity personnel as well. And this is a trend that we've seen over the past decade or more. And what it means is that we have just fewer people that are experts in actually securing such systems. And with this lack of personnel, it means that anyone who does have this expertise that's working to solve these problems may just simply be overworked, and we don't have the capacity to really address the challenges in the way that we need to. And there's also the lack of cyber hygiene still. We always talk about practicing good cyber hygiene, making sure that you're not leaving your systems vulnerable by having your passwords on sticky notes or not having regular backups and these sorts of things. But we still find that there is a lack of these simple and effective practices in securing these kinds of systems. So what we're aiming to do is to provide effective security assurance. So the assurance of these critical systems demands that we have evidence-driven, built-in, and systematic approaches for developing these systems such that we can provide early evidence of mitigating the security risks, attacks, and vulnerabilities. But this is often difficult, costly, and time-consuming. And when we consider trying to do this after the fact, after we've already deployed a system, well, that becomes even more difficult, more costly, and time-consuming. So we want to try to ensure that we have sufficient evidence supporting our assurance claims as early as possible within the development of the system. So for this reason, it becomes important to incorporate security evaluation and assurance in the system development lifecycle. And the argument for the security of these systems needs to be developed alongside the system that it supports. But with security evaluation and assurance comes a number of additional challenges. So there's always trade-offs with security requirements. And this means that the justifications and the rationales for the trade-offs among these competing and sometimes contradictory requirements needs to be sufficiently documented in order to provide this effective assurance. We need to cope with the size and the complexity of these systems. A complete and a holistic understanding of these systems, once all its components are integrated, is needed, but due to the just enormous size and complexity of critical infrastructure, this is often out of reach. So we need more clever ways of dealing with that. There is a lack of security evaluation approaches. There's this intractability of performing a complete coverage of tests that will enable us to guarantee that a system is secure, leading to the problem of trying to show that the system is simply secure enough. We have complications with legacy systems. So the mix of insecure legacy systems in critical infrastructures and the addition of these new technologies as these systems become more modernized and digitalized means that we have these new technologies whose security properties are perhaps not yet proven, being used in conjunction with these legacy systems. And these legacy systems are now being used in ways in which they were never, ever intended. We, of course, have to deal with those third-party suppliers. There's this assumption that the system that we're building, while it may be complex or poorly understood or antiquated in the case of legacy systems, we assume that it's at least built with components that can be trusted and that operate as advertised. But this is not always the case, and this presents a very difficult challenge. We have to worry about the compositionality of security. So with this, we have to worry about the systems that are secure in isolation. Well, they may not be secure when they're composed together. And it can be time consuming to reuse any assurance efforts from our previous versions or parts of the systems. And lastly, it's about more than just the product. Security assurance is not just about the system that we're building, but also about the people and the processes involved. But these requirements are not always explicitly or clearly stated. So how are we addressing some of these challenges? So at the Cybersecurity Evaluation and Assurance Research Lab at Carleton University, we're conducting advanced academic research aiming to develop systematic and rigorous approaches for evaluating and securing and assuring the security of software-dependent systems. This is our main mission. And in doing so, we have a number of research thrust areas that involve security analysis, threat modeling, applying formal methods for security, developing measures and metrics of security, as well as developing assurance case and design patterns for software systems. And we apply this in many different areas, most notably in critical infrastructures, industrial control systems, the IoT, cyber physical systems, and distributed systems. So we really try to encompass a lot of these challenges and address a lot of these challenges that are faced by evaluation and assurance of these critical infrastructure systems. So just to give you an idea of some of the things that we work on baking it in instead of bolting it on. And really, we're trying to answer the question of how can we move away from having security retrofitted or bolted on and start building systems with security baked in at all stages of development. So rather than just having our traditional system development lifecycle, how do we go ahead and add in all of these security engineering activities and have a process by which we can ensure that the system is being properly evaluated and developing and collecting all of the necessary assurance evidence to support any claims that the system is adequately secure. We're also looking at adopting system-level approaches and tools. So how can we address the fact that there are emergent properties, such as security and resilience, of these systems across all of these subjective and contradicting, competing and conflicting needs and beliefs of all the different stakeholders? So some of the ways in which we're trying to address this question is we're looking to develop and adopt streamlined development processes with explicit consideration of risk at all of the different stages. We're looking to adopt a system-level approach to security, which considers connected devices and systems as entities interacting together with all of the people that are involved, as well as its operational environment. We're looking to develop tools that assist in managing the size and complexity of these critical infrastructure systems and supporting these analyses with automation solutions. And lastly, we're looking at developing methodologies, standards, guidelines, and policies to support awareness and enforcement of the different security concerns that are faced by these different systems. We're also looking at improving cybersecurity assurance and evaluation. So how can we be sure that the claims of adequate protection of all of the sensitive information that may exist within critical infrastructure systems, how do we ensure that those are protected against malicious cyber attacks? And how do we ensure that the claims that we're making are well-founded and supported by sound argumentation? So we have lines of work in the area of developing security assurance cases that can enable us to develop sound arguments supported by evidence to support any of the claims we make about the security and the resilience of these kinds of systems. And then finally, we're looking to bridge the technology policy gap. So what we're aiming for here is breaking down the barriers between engineers and policymakers, which often work in isolation from one another. We typically have the policy folks developing the regulations, the standards, the guidelines that help to address a variety of security and resilience challenges. So they may develop some standards, some testing and certification approaches, data and intelligence sharing programs, and help to address some of the privacy considerations. The technology folks, the engineers, for example, are focused on developing those technological advances to address the security and resilience challenges. So they may be using cutting edge technologies like artificial intelligence or blockchain or security automation or autonomous systems, and they're going to be addressing the challenges in that way. And the long-standing barrier that exists is that these two groups have similar goals and objectives, but they don't speak the same language. And this often prevents the realization of the benefits and of their individual contributions. So what we're aiming to do is break down this barrier. And in place of this barrier, we want to start building a bridge. And we want to find a way to harmoniously develop resilient and agile security policies that can keep up with the rapid technological changes that we see in these critical infrastructure systems. So as we start looking forward, when we look at what does the future of critical infrastructure security and assurance look like, well, we're going to have to deal with some future trends because this trend of modernizing and digitalizing critical infrastructure is unlikely to be slowing down anytime soon. So we're going to have to start considering the use of security automation, monitoring, and analytics, and all of the challenges that come with that. We're going to have to look at how do we have better cyber threat intelligence and information sharing? How are we going to deal with the use of more artificial intelligence and machine learning approaches in the development of these critical infrastructure systems and the services that they provide? How do we leverage digital twinning and advanced co-simulation in order to better understand the cyber risks that may exist within these systems? How do we leverage device security, fuzzing, and fingerprinting to really understand the components that are making up these different systems? With the collection of all of the data in these systems, how are we governing all of the data that's being collected? How do we ensure that all of the people involved in the design and the operation of these different critical infrastructure systems are managed such that we have digital identity management and accountability? And how do we have more flexible standards and regulations that can enable and enforce more security concerns to be addressed by the manufacturers, developers, owners, and operators of these systems, while still enabling innovation and modernization of these systems? And these are all going to be challenges that we're going to have to face in the future. And we're really focused on trying to get on the cutting edge of addressing these different concerns. So some recommendations for moving forward with effective security assurance is to look to develop more modular, compositional, and incremental security assurance solutions. This can help us to address the size, the complexity, and the compositionality problems with security evaluation and assurance as it stands today. How can we look to harmonize the security assurance efforts with agile and adaptive development processes? We're starting to be in a much more flexible and agile world, especially when it comes to developing these different kinds of systems. So how do we make sure that our traditionally long and rather bloated security assurance efforts are harmonized and work in tandem with these new development processes? When we come up with new approaches for security evaluation and assurance, we need to make sure that we provide documented demonstrations of their effectiveness so that they can be applied in a practical setting. Again, considering this idea of the practicality of these different approaches, we need to make sure that we develop much more accessible tool support for integrating these automated security analyses into the system development lifecycle. We need to give the developers the tools in order to carry out these analyses and activities in a very seamless way, such that it doesn't get perceived as this extra burden that they need to take on, especially when they may already be overloaded with the tasks that they need to be completing. When it comes to standards, guidelines, and best practices, we need to focus on developing more rigorous, specific, and focused standards. We need to make sure that these are going to provide the actual guidance that we want to see put into practice in the development and operation of such systems. Of course, all of this requires improved collaboration among the various stakeholders throughout the system development lifecycle. When we can bring everyone together and have everyone on the same page, we're going to have a much more effective solution for ensuring the security and the resilience of these complex systems. And last, but certainly not least, we need to work on improving training, education, and awareness of all the personnel that are involved in the development and operation of these systems. And just having conversations with all of the different stakeholders, the wide variety of people that are involved in these systems, is certainly a step forward in this direction. And of course, we can always be doing more. So just to bring us to a close of this presentation, some concluding remarks here is that the challenges of providing effective cybersecurity for these modern and digital critical infrastructures are well known. We've known about this, we talk about this quite a lot, but what we're looking for is how do we practically address those challenges? And what we're finding in the Cybersecurity Evaluation and Assurance Research Lab is that security by design and related approaches and techniques can help to lead towards more comprehensive solutions that are capable of overcoming many of these challenges. And the reason for this is that they're capable of providing that early evidence of mitigating the risks, attacks, and vulnerabilities, and they support the engineering and stakeholder decision-making processes, which is very important when we start looking at how we practically develop these kinds of systems. But of course, there's still lots that can be done, and effort is going to be required to help break down those barriers that currently limit the adoption of a number of existing approaches and techniques. And we need to ensure that all of these approaches are forward-thinking and that they're not going to be a detriment to the innovation that will enable a more effective and sustainable critical infrastructure ecosystem for countries all over the world. And of course, as a final word on this, these challenges are not going to be solved by technology or policy alone. We have to bring everyone together. We have to be working in concert in order to address many of these complex and multidisciplinary challenges that are faced when we look to assurance for critical infrastructure systems. So with that, there are a handful of references related to some of the work that we've been doing in our lab, relevant to the talk that we have today. And with this, we'll pause for a little bit, and I will thank you for your attention for this talk.